My video project is on soybean sclerotinia, or white mold. White mold is a very large concern for soybean farmers as it has the potential to cause high crop yield loss. It is very high impact and can cause up to 50% crop yield, while also causing the seed and crop quality to be diminished. While mold often attacks northern states in Canada and typically comes with yielding increasing practices, such as dense planting and planting early in the season. This disease affects many important crops. Soybeans are one example of the important crops that the white mold affects. Soybeans are a billion-dollar industry and the second most planted crop in the United States, where over 30% of the world's soybeans are produced. And the destruction of these crops by white molds is a critical agricultural issue, especially with the plethora of uses for soybeans. The negative effects of white mold can impact the meat industry, since soybeans often feed meat animals, human consumption of a variety of soy products, as well as the biofuel industry. The effects of mold are far-reaching. Let's look at the disease triangle for white mold. First, we have the pathogens. Sclerotinia sclerotorium, Sclerotinia minor, and Sclerotinia trifoliarum are all potential pathogens that can cause this disease, but Sclerotinia sclerotorium is the most common and found in soybeans. White mold accounts have been known for many years, but it wasn't until the 1800s that this disease was recorded and officially labeled. Because the disease was noted on several different plants, each pathogen was given its own name based on the plants where its symptoms were most often shown. Moist environments are ideal for the growth of white mold. Nearly saturated soil and cool conditions promote growth, which means seasons with high rain and high humidity are far more likely to have higher incidences of white mold. There are many potential host plants for this disease, all of which are critical to our economy, such as legumes, sunflowers, most vegetables, canola, tobacco, flowering bed plants, and stone fruits. All give opportunity for the white mold to thrive, and this decreases the health of all of these plants. The disease cycle for the white mold begins with the Sclerotinia sclerotorium in the soil, as seen at the very bottom in image A. They then germinate to produce tiny structures called apothecia in image B. These apothecia then produce acrospores, which are simply the spores released by this mold. These acrospores then infect the host plant. These spores colonize flowers, which enables them to infect and spread to the rest of the stem and nodes, as seen in image D at the top of the panel. The first signs are white mycelium that just appear as soft white tufts on the plant, as seen in image E. Some symptoms also include bleached stem lesions, wilting of the host plant, and death of the plant or no seeds or pods produced on the host plant. When seeds or pods are produced, they may lack any seeds within the pods, and new sclerotoria form around the pods and stems and fall back into the soil during harvest, and the cycle starts all over again. Managing white mold is most effective when it is prevented. A few management ways include crop rotation, tilling, and effective planting. Rotating the soybean crops with non-host crops such as corns or grains for 2 to 3 years can reduce the potential of white mold. Not tilling too deep and planting with sufficient space can also encourage circulation of air and ensure moisture isn't trapped, which can also prevent mold. Other ways to manage white mold is to treat the crops with fungicides, although nothing currently available is completely effective in treating the mold. Chemicals that delay flowering also help in the prevention of white mold as well, to allow the plants to be less susceptible to the white mold spores. Here are some additional resources to find more information on Sclerotinia sclerotorium, or white mold.